Today we're going to talk about 9.1 and 9.3, at least part of 9.3, restrictions and simplifying rational expressions. So one of the first things I want to talk about is what is a rational expression. Well, rational expression is simply a function that is written as a ratio of polynomials. If you remember polynomials, binomials, monomials, trinomials, all that stuff. Down here, if you look, you see we have a bunch of examples of rational expressions. The fact that it's a ratio is just basically just kind of a fancy way to say that it's going to be a fraction. Now, what's a restriction? Well, we're going to come back to that here in just a second. What I would like to talk about is how do you simplify rational expressions? Well, the way you simplify rational expressions is you're going to follow this basic rule. You can cancel factors, not terms. So in order to follow that rule, you obviously need to know what a factor and term are going to be. Well, a factor and term, well, let's start with term. Term is simply an expression. Could be a variable, could be a number, could be a combination of those two. That could be separated by an addition or subtraction sign. So as I look at this top one, I see that this is a factor because there's a subtraction sign next to it. This is a factor because there's subtraction signs on either side, and 21 is a factor. Or sorry, switch that. These are all terms. X squared is a term because of the minus sign. 4x is a term because of these minus signs. And 21 is a term. And the same thing with all these on the bottom. X squared, x, and 6, they're all terms. So that means we can't cancel these out. You can't just cross out these x squareds like that. So what you need to do is you need to create some factors. Well, how do you create factors? Well, you factor. So that's what we're going to do. We're just going to look at it and decide, all right, well, how do I factor this? Well, as I look at this top one, I see that it's going to factor x minus 7, x plus 3. And on the bottom, it factors to be x plus 3, x minus 2. And so what that does is now that created factors. This x minus 7 and x plus 3, those are factors because they're separated by a multiplication sign. And x plus 3 and x minus 2 are factors because, again, they're separated by multiplication. So what does that mean? That means I can cancel. I can just cancel these out. Now, I can't cancel those, so I'm going to have x minus 7 over x minus 2. And that's it. That's my answer. That's the most I can reduce this expression down to here. Now, that wasn't super hard. But we also need to talk about this part. What does the word restriction mean? Well, restriction would mean something like you can't do it. You know, if you're put on restriction, might be you're being in punishment. You can't go out and play with your friends or drive your car or whatever. Well, restriction in terms of a rational expression is if I were to plug numbers in to this, what numbers would I not be allowed to plug in? Well, that's easy enough. If you have a fraction, what part of the fraction or what numbers could you not plug into a fraction? Well, you can plug in any number you want to the top of a fraction, but on the bottom, you can't have 0. So our restrictions for these are going to be any numbers that I plug into the bottom that will make it 0. So to figure out my restriction, it's very easy. I'm just going to take my bottom. I'm going to set it not equal to 0 because the bottom can't equal 0. And then I'm just going to factor. X plus 3, x minus 2. We've already done this factoring to the left over here. Set them both not equal to 0. Solve. So my restrictions are this. X can't be negative 3, and it can't be 2. And my answer to simplifying is this. Okay, so for all these, you should be able to come up with restrictions, and you should be able to come up with a simplified version. Okay? So let's try the second one. Now, as we go, you can make this pretty easy. If you just wanted to try this on your own, you can always pause what I'm doing, try it on your own, and then go from there. So let's start with restrictions first. Okay, restrictions. So I'm going to take my bottom. I'm going to set it not equal to 0. Again, it's always the bottom. It's never the top, because we don't care if the top is 0. If the fraction has 0 on top, then the whole thing is just 0, so that's no big deal. So let's see if we can factor this thing. All right. I'm guessing it's going to be 3x and x. And then most likely, it looks like it's going to be plus 2 and plus 4. That seems to work. Set them both equal to, not equal to 0, that is. So I get, when I simplify all this, x could not be negative 4/3, and it could not be negative 2. So if I actually set this equal to 0 and made this an equation, two numbers that could not be possible solutions would be these two numbers right here. Now that's going to become helpful down the line. We're going to talk about rational equations later on. So this is just kind of a practice run for us. Now this doesn't have equal 0, so let's get rid of that. And let's get down to simplifying this. Well, the nice part about doing the restrictions is you've already done the work on factoring. So I can factor the bottom. Right here it says 3x plus 4 and x plus 2. So let's see about the top. Alrighty. Well, it's minus 2, so that means one's going to have to be minus, the other's plus. Let's think about this here for a second. So I got a feeling it's going to be 3x and 2x. And then probably, I'm guessing it's going to be, looks like it's going to have to be a negative 2 and then a positive 1. So that'll give me negative 4x, 3x. Yep, that'll work just fine. All right, so I look at this. All right, so I factored everything. 3x minus 2, 2x plus 1, 3x plus 4, x plus 2. Now I look at this, and this will happen occasionally, where nothing factors. So that means this can't be reduced. Now, for our sake, well, to be completely simplified, you should multiply these all back together. So in other words, get back to this. Now I'll give you a little bit of a break. You can actually leave your answer like this if you would like. You don't actually have to multiply it back together. In this case, it's easy because you know what it is, because we didn't really do anything. So in this case, not super exciting, and it happens occasionally, where nothing reduces. So it actually was simplified. Now, how do you know that beforehand? Well, you don't necessarily always know that beforehand. You actually just have to work it out. But we did figure out some restrictions. All right, let's try one more. Let's see if you can do this on your own. I would suggest hitting pause. I'll give you a little hint. This is the difference of two cubes. And see if you can simplify it. And also figure out your restrictions. All right, well, hopefully you hit pause. If you didn't hit pause, oh well, then let's just do it anyways. So restrictions. So x squared plus 2x plus 4 can't be 0. Now that one's going to be a little tricky. That one right there is going to be one that is not going to factor. So I'm going to leave that just for a second and let you think about how you'd figure out what the zeros are, or the restrictions are. But let's come back to this one. Factor the top. Let's see. So we're going to factor. If you remember SOAP, same, opposite, always positive for my sign. So same, opposite, always positive. Looks like it's going to be x minus 2, x squared, 2x plus 4. Now this one, you notice, we have a factor. Well, this is the whole thing right here. We can now cancel with here and here. So I'm just left with x minus 2. So I'm done. But we still have one last thing, and that is, what about this restriction over here? Well, how do I do that? Well, you're going to have to go through and do quadratic formula, complete the square, anything like that. So that's going to take a moment here. So if I end up going through and doing that, I'll end up, let's see, how about we complete the square? So x squared plus 2x can't equal negative 4. Divide by 2 and square it. Add 1, add 1. Factor.